guys, welcome to the Backyard Machine Shop. Well, in our last video, we started up the lathe, ran in the spindle for a while, made sure everything was going to run halfway decent. We played with the feeds and speeds a little bit, the gearbox, make sure everything worked there, and we actually made a couple cuts. And I don't even think I measured those cuts, but I just wanted to make some cuts and show that the lathe would cut. So we're going to make it one step further now. So what we're going to do in this video coming up is we're actually going to make some test cuts. We're going to set up our tailstock, align our tailstock, and then make some test cuts behind that, and kind of see what the lathe can do and the accuracy of the lathe. So what I've done is, the first thing was I made two test bars. I made a test bar here that's 2.5 inches between centers. It's about 3/4 inch registered surface. And what we're doing with this test bar is we're actually mounting it in the chuck. And we're going to come in and make a pass on these two surfaces, measure them, and that will give us how the lathe's cutting in a 2.5 inch space. About, well, you'll see, it was probably a good 5 inches out from the chuck. Okay, so next thing we did was we made another test bar, and we made these test bars over on our Kingston lathe, on my Kingston lathe. This test bar has two registered surfaces 7 inches apart. Now you ask, why 7 inches? Well, I had a piece of material that long, and I needed an area to hold the material with the dog, so 7 inches. So we took this and we made test cuts with it also, and you'll see what kind of results we got. We actually turned this piece between centers, and that will show your true. It took the chuck out of the equation, did the whole thing, and tells you exactly what you're doing. This one we turned into chuck. Now once you turn it, it'll be whatever the chuck's doing, but you don't know if it's aligned with the tailstock or not. So you remember the tailstock, we got the new quill in the tailstock. This is the one we made in the videos of machining a tailstock quill 1 and 2 and 3, whatever it was. So it's also, see the performance of that. Now that quill works real well. It as far as the taper and all that in it, works really well. We've had, what else did we do in this video? That's pretty much it. So guys, after the video, I'm gonna come back and we're gonna have answer some of your questions and show you a few more things about the lathe. Okay, so I hope you enjoyed the video, and see you at the end. All right guys, so working on the Pratt and Whitney some more, and what we're doing today is we're going to test it. We're going to do some test cuts, see how well it's cutting, and how accurate it is. And the next thing we're going to do is then we're going to take and we're going to align our tailstock and get it all trued up. And remember, this is the quill that I made, so we don't even know how accurate that quill is. So we're going to work on that today. So what we're going to use is I've turned a couple of test pieces on the Kingston, and this one's to turn without the tailstock, just to see how accurate it is. Anything beyond, I don't know, this is maybe 3 inches. I'd say anything beyond that, you had to start dealing with tool flex. So I just made it 3 inches. And then this one, we're going to turn between centers. And I've got it turned already. I used the Kingston, I dialed the Kingston in. I've got it within 2/10 on each register here. So we're going to take and put this in there and use this to align the tailstock. So what I got to do now is we're going to take and turn the smaller one and see what we get on it, and then we're going to put a center there, dial in a center, and put a center in the tailstock, and let's dial the tailstock in, and then we'll make some cuts like that. Alright, so stand by and I'll get set up. So I got you over, and we got the test bar in, and we're going to measure it out. Like I said, I cut these on the Kingston, and right now we're measuring on that front journal, we're at 1 inch, 440, 1, 2, 3, 43 and a half. In a back journal, we're measuring 1 inch, 443 or 42 and 9/10. So we're 4/10 off the bat. So I hope we can stay that close with this thing. All right, so we're going to start out in probably third gear or second gear. Okay, now these were cut on the Kingston. They were cut in a 4-jaw chuck, and it was indicated in on this back. And there's a little bit of run out in this lathe chuck. I think it was like 6 thousandths when I checked it. So anyway, we're going to cut this at, and what we're going to do is we're just going to make a light pass, maybe 10 or 15 thousandths, and cut both registers and then remeasure. Now I've just honed this this cutter, and the lathe probably. Let me warm this lathe up a minute, and then we'll come right back. So what I said, we're going to cut these 2 registers, measure them, and see how close this lathe is cutting. Now I expect to have a few tenths of. That's what happened over on the Kingston. There's probably since this one's a little wider, a couple of tenths wider, it's probably due to a little bit of flexing, so we'll see. All right. But I'm gonna go ahead and cut deep enough to get rid of this run out on both of them, and then we'll come back to and measure them. Okay, so see what we get this time. All right, so 424. Still getting 428 thousandths. I didn't take nothing off. $426,000. Give it a whole double check. Yeah, 426, 426. Looks like it's 426 even again. Okay, so let's check this other side. Four, 2, 6 and 7/10. So we're cutting 7/10 off. We're cutting 7/10 bigger here than we are here. That don't make sense. No, I read it wrong. I read it wrong. Hold on, let's do it again. All right, so we're at 4.2. We're at 426. This time I got 1/10. Okay, so 426 and 1/10. Okay. All right, so we got, instead of 426, we got 425 and 9/10 that time. So 4.259. So what we got here, we have a center, and it's at a 60-degree included angle, just like the center drill. And we've got our compound turned to 60 degrees. Some compounds it'll be 30. It'll be the actual angle. Some compounds it'll show you the included angle, or what it does, it shows you from 0, I guess, on this lathe would be, or 90 degrees would be this way, and some lathes 90 degrees or 0 or 90 degrees would be that way. So we've got it set on 60. I had to put about 60,000 shims in this thing to get it up the center, and I hope I got it up far enough. So we're going to try to cut this center. If this don't work, we're going to have to go to a plan B. This is about the only way you can actually get your center true. All right, guys, so now we've got a true center, and we're going to take and change our compound back around. Maybe we've been a little low on it the whole time. That's good. All right, guys, so I got you set up. We can tighten that up just a little bit. All right. I've got you set up here, and I already see one problem. It's a little minor problem. Let's adjust this to 0. If you notice, I got the indicator sitting up on top of the test tool. Now, one of the things I was concerned about was this whole setup. You remember there's some shims in the tailstock, so that told me that there was some wear in the tailstock or something wasn't right with the tailstock when it was put together. So first thing I've checked here, since I've got an alignment thing here, and we're not going to do anything until we get everything set, but I pushed the tailstock in the center here together, and they were pretty close, and it may be 0.003 off, but right now if you look, we're at 0, and then we're at 2, just past 2, maybe 2 and a piece, a quarter thou low on that back side. And it's true. I'm gonna crank it up and run it. It's bouncing around back and forth on the thou. You want to come over here and look. See, it's bouncing back and forth about a thou. All right, guys, so we got a setup here, and what we're going to do is we're going to run this indicator. And this is a Mitutoyo 10th indicator, and I've already checked it with the other indicator, and I can't believe as close as it is because I hadn't done anything to it. But we're going to run this indicator in and get it to 0. Now the whole thing is, this thing needs to be straight. Remember, we're 2/10 up here already on diameter, so we've cut a slight taper, so we need to get that taper out, and the way we're going to do that is by setting this thing up with this indicator. So we're going to bring this to 0. Alright, so we're reading 0. Can you see that? Alright, I'm going to leave you right there. Maybe we can work around that. Okay, so we're at 0 on that surface. Now this surface was bigger back here, so it should be a couple thousandths or a couple of tenths. Well, we hadn't got it set up yet, so we don't know. But we're going to run it back, and this indicator here was about 2 thousandths. So we'll see what this one is. All right, so we've fallen off. Come on, there we go. All right, so we're away to the back of the lathe, what looks to be about right at 2 thousandths, just what the other indicator was saying. The way we need to adjust this lathe, there's 2 bolts, one here and there's one on this back side. Okay, what we have to do, these things are jammed together, so we have to loosen one and bring it over. So we need to bring that over to 0, and so we're going to loosen this nut or this bolt. Look at that, it came over by itself. Look at how much spring was in that. this is going to be one of them cat and mouse games. Alright, so there. Now we're on 0. Let's run the lathe back down. Alright, so now we're at a half a thou. Okay. See if we can get that adjusted out. All right, we're reading 6/10 right there. Zero. All right, so we're 1/10. Let's give it that 10th. I'm gonna call that nuts, guys. All right, guys. So what we're fixing to do, we're going to come in here and make a pass over these two surfaces here, and maybe take a 15 or 20 thousandths cut, and we're gonna measure them, and they should be within a few tenths if everything holds up true. So stand by, make sure you're recording. Get you a good shot at it there. All right, let's cross your fingers and let's go. Okay, we're gonna move in about 12 thousandths. Touched again. All right, guys, so they're nice and cooled off, we wiped off. Let's check them out, see what we get. All right, I got 1 inch, or I'm sorry, just a 2 to 3 mic, 2 inches, 393 and 1/10. Okay, 2.3931. Okay, let's see what we get on this one. Can't be that. All right. 2 inches, 393. I say 93.0. 2.3930. So we're 1/10 off. Let's check them again because I didn't think they would be that close. Just all right. So if you want to look at it, we're at 2 inches. 393.0 that time. That's what we had. But let's see. I don't think I'm square. Feels good right there. All right. Same thing. All right, so that time we got 2 inches, 930, or 2 inches, 392.28. So still getting within 2/10. I don't believe it's that low because this should be the higher number, but get away from that. All right, guys, I hope you enjoyed that. I was very shocked at how well this lathe actually cut and what kind of performance. But you know, that just goes to show you. Well, let's back up a little bit. One of the things I did to set this lathe up beforehand, before I ever put the motor mount and or got the belt on and actually turned it on, is I took about a half a day and leveled this lathe out the way it should be leveled. I mean, we've got it within a 1/2 thousandths per foot in all three areas here on the ways. Now, leveling it in this direction, you know, it really don't matter. But you need to get the ways level with each other and parallel with each other to where if there's any twist in the lathe, take all that out. And you can actually, if you got a lathe that's got some wear in it, you can actually put twist in the lathe and make your lathe cut a little bit better. But anyway, we went in here a day or two before we got it running, and we spent as much time as it took to get this thing leveled. And then when I leveled it with 3 feet. You try to always use 3 feet or three points. So basically, I used the 2 back points and one of the front points, and that way it lets you take the twist out. And then what you do is when you get it level, you just drop the 4th leg down and kind of snug it and make sure it stays level. Someone had asked me about the feet, thought they were rubber. They're not rubber, they're steel. They're 8620 actually. There's some slugs that I got out of a water jet part at work, and every time we run that part, I grab the slugs and you know, they've got a little nick in them where you got your lead in and lead out in the water jet, but I use them for feet. I've got them on this machine, I got them on two of the mills and I think the Monarch. So, you know, I use whatever you can, you know, you don't waste anything. Next thing is the rod in the back. All right, I get a lot of discussion about that. And then this rod is original to the lathe. And the reason I know that is, and it's also, I got some theory to it. Let me explain the theory before I show you what I got. The original lathe, I can say the original lathe. I got three-time dated photos or sketches of this lathe. One was in 1907, and it's in the lathe builder's book. Kenneth Cope, I think is what his name is. Anyway, it shows the lathe, and this is about the time they patented the gearbox. Now the last patent I had is 1909. So this lathe was built after 1909. I know that, but it's got a 1907 patent in it, a 1905, a 1904, and 1903. So this lathe's been around for that long, and it may be been around longer than that. But I think they patented the gearbox in 1907, according to Kenneth Cope. Okay, so in the 1907 picture, it's kind of just a sketch, and there's a few things that's not on here, but the gearbox is, if you look at the lathe right here, that's what you have. And I don't have it with me out here. I'll have to show that in a later video. But this is the same, and there's a couple things, and the rod is missing. Okay, the next sketch I have of this lathe, and I do have it with me. Let's see. Okay, so this came out of a book online that I got from, I think it was off Practical Machinist, and then there was a link I found to a library out in California. Anyway, inside the book, flip over to a couple pages, there's a date stamp, 1912. Okay, so I'm assuming that this is probably either 1912, 1911, somewhere in there. So that book was entered into that library in 1912. So, and this is the picture from that catalog, and this is the Pratt and Whitney catalog, and I think it's called Precision Machine Tools or Precision Tools. But anyway, if you notice, there is no rod. Okay, the quick change is there, and one of the differences we're going to see is there's a little handle right here, and that handle actually reverses the feed on the lathe. Now, I don't know if that was a bad design, people didn't like it or what, but you can tell it's not here. Now, if you look at the back of the lathe, this is a picture of the back of the lathe in 1911. It has, where that mount is, it actually has a mount for the collets. Now, I actually have the collets and everything for this lathe, the collet closer. The only thing I'm missing is the adapter and the spindle. Well, the taper attachment's there, and there's nothing in this area about a relieving attachment that is in there. But right behind that area would be that rod that goes through. Okay, so this is 1911, and you can see there. Okay, so the next photo or the book I picked up or picture that I received is, and I'm guessing around 1916 to 1920. I have no way of really dating it, just assuming, okay? It could be late, mid-20s, I don't know. But anyway, here is this picture, okay? So this picture, it actually has the rod located in it. Now, if you look, I don't see the holes, and I can't see the holes in the picture that's in the actual rod. Maybe they were there, maybe they weren't, I can't tell you. And the back side of the lathe here, if you look, you can see that they pulled the rod out, that shift rod out, and that's actually what controls and what reverses the feeds. Sorry about that. I rambled on for another 10 minutes or so about the lathe, and went back and checked what I was doing, and the memory card had filled up. So back to, I watched where I was at, and what I was getting at was my theory about this bar was that it was a replacement for that handle. I don't think that handle was doing a great job. Here's the other memory card. I don't think that handle was doing a great job, or maybe it was more expensive to produce, or maybe they needed a way to get it automated. I don't know, you know, whatever it was. I think they replaced that handle with this one, and either maybe for automation, you know. So, you know, the other things that I wanted to talk about on the lathe was, you know, it cut really good. I'm really proud of it. I'm ready to make some more parts on it. I want to get into, I want to cut a thread on it, and because it's a little different than anything I've ever cut a thread on. I want to, I actually have made the first parts off of it, which were a couple little screws that plug the oiler for the carriage. It's actually got felt oilers underneath the carriage, and it's got 4 screws in it, and 2 of them were missing. It's the only 2 screws the whole lathe that I had missing, and they're here somewhere. I put them somewhere doing something with them. I don't know what I did with them. I have my table, all my bags, I went through everything. I cannot find them, so I went ahead and made 2. And it was a pretty simple process. The only thing is they're 5/16 20 thread. I had to do a little bit of, well, I actually had a 5/16 20 die, so that was no problem threading them. The only problem I had was making a way to hold them to where I could slit them with it on a mill. And basically 5/16 20 and M8 1.25 are the same. There's like 0.8 difference between the pitch of the thread. So they're basically the same thread. If I'd known that, well, I still would have made a correct one. But I did use an M8 125 tap to tap a block to hold the screws while I slit them. Other than that, man, I'm stoked about the lathe. It's getting used to the running. I need to clean it back up, but you know, I'm super stoked. So, guys, with that said, I'm gonna close it off right there. We'll get back to some more parts and some more things later. I hope everybody enjoyed the video and enjoyed seeing what it would do. And until next time from the Backyard Machine Shop, so long. So guys, one more thing. Keep the comments coming. I know I haven't answered all of them from the last video. There was just so many of them, and I've been kind of, this is the weekend, and I did this right before I went back to work, and I try to answer a few every night. And last night I took my wife and my mother-in-law and my mom out to dinner, and kind of, you know, just had a good time. So I didn't get to any last night, but anyway, keep the comments coming, keep the suggestions coming. No matter what it is, throw it out there, we'll look at it. So again, thank you, and so long.